When dealing with the normal distribution, what we're interested in is where a score is placed relative to the mean, and normally in lots or in multiples of the standard deviation. So we talk about a score being 1 standard deviation above or below the mean, or 2 standard deviations above or below the mean, and so on. However, sometimes it can complicate things, and all we're interested in though is just the number of standard deviations away from the mean. We don't even care what the mean is so much. It's more how far a score is, or a particular score is, away from the mean of that whole set. And we talk about this concept of a Z-score then. So what is a Z-score? A Z-score, Forrest Score, indicates how many standard deviations away from the mean that score is, and that can be in either direction. So as an example, a set of exam scores has a mean of 80 and a standard deviation of 5. A student scored 70 in that exam, which is 2 standard deviations below the mean. That student's Z-score would be -2 or -2. Okay, so you're counting the number of standard deviations. So if I was to draw that on a number line, okay, or a Z-score line, okay, so the average there would be 80. Okay, 1 standard deviation above would be 85. 2 standard deviations above would be 90. 1 standard deviation below would be 75. 2 standard deviations below would be 70. So if we're counting the number of standard deviations, or in lots of standard deviation, each standard deviation is worth 5. So if that's the mean, this is +1 standard deviation. This is +2 standard deviations. The mean itself is 0 standard deviations because it's the average itself is on the average itself. So it's not either side. 75. That score is -1 standard deviation below the mean. 70 is -2 standard deviations below the mean. Now, recall this. This is from the NESA reference sheet, okay, and this featured in a previous video. If I just zoom in on that, okay, so we'll have a look at this one more time, and we can see here that when we're talking about -2 standard deviations, we're actually in the lower, or the bottom 2.5%. Okay, that tail here, 2.35 plus 0.15, that's 2.5%. Okay, so the Z-score, and that's all we need. The Z-score tells us where in the normal distribution that score is in fact located, based on how far away it is from the average. It's got nothing to do with the average itself. It doesn't matter. All we want to know is how far from the average that score is. So how do we work this out? Okay. As always, what's maths without a formula? So to calculate the Z-score, the Z-score is the score minus the mean divided by the standard deviation. So if we took that last example, okay, so that last example, that student's score was 70. Okay. The mean of that set of exams was 80, and the standard deviation was 5. Okay, so just remind you quickly. Okay, that's that. The mean is 80, standard deviation of 5. The student scored 70. What would that student's Z-score be? And we did work it out to be -2. Does it work using the formula? 70 minus 80 is equal to -10 over 5. -10 over 5 is equal to -2. So that student's Z-score would be -2. Now, in terms of the formula itself, in using the correct symbols and the notation, there's one of 2 forms. Okay, we can either use the mean and the standard deviation using the symbols for a sample, which is x bar, and the letter S, a small letter S for the standard deviation for a sample, or we could use mu, okay, which is the Greek letter, the lowercase m, or the Greek letter sigma, so it's a lowercase s in Greek, for a population. Okay, but either one refers to the same basic thing. Right? We're comparing a score to the mean of those scores, and then we divide it by the standard deviation to work out how many standard deviations away we are. Now, one other point is that the distribution of Z-scores is itself a normal distribution. It has a mean of 0 and a standard deviation of 1. I'll just refer back to the reference sheet again. Okay. And we can see that here as well. The mean is in the center. So the mean has, well, the mean in this case is 0. So this is for Z-scores, when you work out the Z-scores, and standard deviation is 1. So there's 1 standard deviation above the mean. -1 standard deviations below the mean. Okay, -2 standard deviations, -3, and so on. Okay. And then we can use that then to perform all manner of calculations. Okay. In the next video, I will be looking at some examples involving Z-scores, and they're very handy when working out basically how someone scored compared to the mean and the standard deviation as well.